The figure shows the basic block diagram of a digital computer. The major component is the central processing unit, which is like a brain of our human being. The next component is the input unit. The input unit is used to give the input to the CPU. The examples of input units are keyboard and mouse. The another component is the output unit, which is used to view the processed output. The examples of the output units are computer monitor, printer and plotter. Yet another component is the memory unit, which is used to store the program as well as data. Three major parts of the central processing unit are: number one is ALU, arithmetic and logic unit. Whatever may be the arithmetical and logical operations, that will be done only within the ALU. Number two is CU, control unit, which is used to provide timing and control signals as well as the synchronization signals whenever a data is read or write from memory or from peripheral devices. Number three is a small register array which are available within the CPU. In the case of microprocessor, all the three units, that is ALU, CU and register array, are fabricated in a single IC. So the perfect definition of a microprocessor is a single chip CPU. A computer which uses the microprocessor as the CPU is known as microcomputer. Almost all the systems what we are having in our laboratory, all are microcomputers. If you want to thoroughly study about the microprocessor, it may be any type, or 8-bit CPU, 16-bit CPU, or Intel or Motorola series, whatever it may be. Some of the important terms and definitions used in this field are to be known. Let us discuss the important terms and definitions used in the area of microprocessor. The first important term which we should familiarize is about the bus architecture. The bus architecture consists of three different buses. Number one is an address bus, number two is a data bus, number three is a control bus. Irrespective of any processor, this bus architecture is a must. The address bus is a unidirectional bus. It determines the maximum memory capacity of any processor. It is used to point the input, output as well as the memory. So by using the address bus, we can point the input devices, output devices, and we can locate memory locations from the memory IC. The number of address lines is the factor which will determine the maximum memory capacity of any processor. If a microprocessor consists of only two address lines, the number of addressable locations are, the two address lines may have, that is the A0 and the A1 may have the values of 00, 01, 10 and 11. So we can have four different locations with two address lines. If a microprocessor has three address lines, A0, A1, A2, then all the three lanes may be 000, 001, 111. That is the number of combinations are 8. That is 2 to the power of 3 is 8. So if the number of address lines are increased, the addressable locations also will increase. If you take a typical processor of 8085, the number of address lines available are 16. So the maximum addressable locations that can be interfaced with the 8085 microprocessor is 2 to the power of 16, which is equal to 65,536. If you divide 65,536 by 1024, you will get 64K. That is, 64K is the maximum addressable memory locations with respect to 8085. This 64K is not sufficient. That is why the people have gone for higher-end processor like 8086. In the case of 8086, the number of address lines are 20. So the maximum possible addressable locations are 2 to the power of 20, which is equal to 2 to the power of 10 into 2 to the power of 10, which is equal to 1K into 1K, which is equal to 1 MB. Even this 1 MB is not sufficient. That is why the people have gone for still higher end processors, and today we are with the Intel Dual Core processor. So in general, we can write 2 to the power of x equal to n, where x is the number of address lines and n is the number of locations. The next bus is a data bus. It is a bidirectional bus through which only the data can flow between microprocessor and memory, as well as between microprocessor and peripheral devices. It is used to fetch the data from the memory and I/O devices, which is used to write the data to the memory and I/O devices. Generally, the number of address lines, they call it as a word length of a particular CPU processor. If the word length is 8, that means simultaneously it can handle with 2 8-bit data. In the case of 8085, the word length is 8. In the case of 8086, the word length is 16. That means it can handle 2 16-bit data simultaneously. The next bus is a control bus. Control bus carries the synchronization signals and timing signals. It carries control signals from processor to memory and peripherals. The example of the control signals are IO bar, M bar, read bar and write bar. Suppose if a CPU wants to read a data from some memory location, first of all the address bus will be placed in the address bus. Using the address bus, it will point to the particular memory location in the memory IC. Then the control unit will generate IO bar, M bar and read bar signal. That is IO bar, M bar signal as well as the read bar signal should go low during the second T state in order to enable the memory, so that the addressable from that particular memory location, the data is placed into the database and it can be read by the CPU. The another important parameter or factor which should know in the area of microprocessor field is clock. So irrespective of the processor, all the processor should be driven with the clock. It is nothing but a crystal oscillator which will determine the speed of the processor. If we take 8085, right, the operating frequency, it varies from 2 MHz to 3.6 MHz. That means it will generate 2 into 10 to the power of 6 T states per second. In order to execute one instruction in the case of 8085, it requires 4 T state. So we can compute how many instructions can be executed per second. So the people are trying to increase the clocks because we want to have more speed. They started from 4-bit CPU, 8-bit CPU, 16-bit CPU, 32-bit CPU. We want to increase the memory, started from 64K, 1 MB, then 1 GB, 4 GB. And similarly, the another way of increasing the speed is to increasing the clock rate. Right? So based on these 3 factors mainly, this table shows the comparison of some well-known processors. Right? So if you take the first processor listed on the table is 8085, where the clock rate is 2 MHz, number of data bus is 8, so I can say that the word length is 8. The number of address buses is 16, so the maximum addressable capacity is 2 to the power of 16, which is equal to 64 KB. The number of transistors used are 6500. The features are, it has a serial I/O, that is, it has the 2 lines called SID and SOD, and it has 3 maskable interrupts. One is RST 7.5, RST 6.5, RST 5.5, one non-maskable interrupt, that is trap, one externally expandable interrupt, it is INTR. So consider the next processor 8086 or 8088, where the operating frequency varies between 4.77 MHz to 10 MHz. The number of data buses are 16, the number of address bus is 20. So the addressable capacity is 2 to the power of 20, which is equal to 1 MB. Number of transistors used are 29,000. Here the special feature is it uses the segment registers. So using the segment register, it is possible to access more than 64 KB of data at once. That is the important feature. The next processor is 8186, the operating frequency is 6 MHz. Here also the data bus is 16, address bus is 20. It also uses 29,000 transistors. But if you look into the special feature, it has a built-in 2 timers, and it has a built-in DMA controller and an interrupt controller on the chip in addition to the processor. And similarly, Next improvement is 8286, where the number of address lines has 24, so the addressable memory will become 2 to the power of 24, which is equal to 16 MB. And the next one is 8386 SX, which also consists of 24 address lines. And you can look into the special features. The internal architecture is 32 bits. The externally it has only 16-bit data bus, but internally it can manipulate two 32-bit data. That is a special feature of this 386SX. Then you have 386 SL. Here the data bus size is 32, so we can say that the word length of this processor is 32, the address bus is 32, so the addressable capacity becomes 2 to the power of 32, which is equal to 4 GB. The next version is 8486DX. The next one is 8486DX2, where I can say it's a dual exchange processor. Then 8486SL, which is exclusively designed for embedded systems. Then 8486DX4, and we have Pentium processors. And now we are in the verge of Intel Core 2 Duo, where the operating frequency up to 3.1 GHz is available in the market. The addressable capacity will become 4 GB.